the for loop. And that's the first algorithm that I wanted to tell my story through, is the for loop, the humble for loop, right? That's what computers are best at. Repetition. So, like I said, I went to undergrad without knowing how to code. And so I did this in an undergrad class. And I came in with a painting portfolio, and then I wouldn't necessarily say I catfished them, but I came in with a painting portfolio, and then I never made a painting while I was there. And instead I switched to computers. Yes. And this was the computer that I spent, about maybe like 20 hours a day on, trying to learn code. And this was at Carnegie Mellon University, so there was a lot of mathletes around me. So I spent a lot of time on my computer trying to catch up. And on this computer, I wrote a manifesto, and my computer was named Charbot. And this manifesto, I start a lot of my talks with this manifesto because it's still a through line in a lot of the work that I do today. And I'm just going to read the last line. The manifesto is called "My Keystrokes Are Me." And it says, "I call for the following: to problematize technological determinism while empowering human agency." And so I studied computer science, and I graduated, and I got a day job in software engineering, as one does to make money to eat. But the artist's life still called to me. And so in the after hours and weekends, I would do this thing that y'all might have heard of, called live coding. Maybe we could have it a smidge lower. Perfect, okay. So my particular way of approaching live coding is that I like to take code to places where code really should not go. So festivals, and there was a bathhouse in Pittsburgh that I performed at. I really liked. And I was really thinking a lot about how when someone goes to a festival, they're not necessarily expecting to be confronted by linear algebra. And so the interface, the IDE, is something that they would see. The first thing they see is the IDE. And because they're new to coding, they wouldn't necessarily know the conventions of an IDE. So I was thinking, a lot about IDEs. And that's where this kind of planted the seed. But, before I was thinking about interfaces, I was also so moved by how coding brought so much agency into my life. And so a question that I had, after doing a lot of live coding was, how can we inspire learning and community through creative code, right? So I think that to learn something yourself, a really good way to cement that learning is to teach it. So I started teaching a lot of workshops. So at this point, I have graduated from my undergrad, and I'm live coding, and then I wanted to kind of perpetuate more live coding, live coding begets more live coding. And I taught shader workshops, right? So, and I wanted to tell you about my next algorithm through this story. It is the algorithm that I would teach my students. And it's, to this day, my favorite algorithm. I wonder if anyone knows what I'm talking about, but if you guessed ray marching, you might be correct. So ray marching is an algorithm that is physically based-ish. This is a picture that I made for my students to kind of explain what's happening. So you can create a tiny renderer in about 200 lines of code, right? That can actually fit on a screen if you make the code small enough, so, and it works by casting eye rays into a 3D scene that's defined by what is known as signed distance functions, which is a way to describe a surface using mathematical formulas. I'm not going to go into like the nitty-gritty details of exactly how it works. The hand-wavy explanation is that it works kind of how Plato thought vision worked, right? So it's called emissive theory. Plato thought that how we saw was that folks would cast eye feelers into the world, and the eye feelers would touch everything and then go back into your eyes and then tell you what was there. He wasn't super wrong because it kind of works the opposite way, that photons are emitted from a light source and then they bounce into your eyes. So it's not super wrong, but it's better for computers because then that means that you don't have to render things that you don't look at. So you can technically do, yeah, anyways. So that's still to this day my favorite algorithm. So I was teaching these workshops and live coding, and I wanted to have space and time to ask bigger questions. So I applied to grad school. Whoa! And the particular group that I was in is Future Sketches. And I recently graduated this past summer. And we were the group led by Zach Lieberman. He's in the top right corner over there. We were the group that worked at the intersection of art, technology, and design. And again, this question that I have been thinking about before, when I was live coding of the interface, started to come up again. This is usually how I would code. Well, this is a shader. That's all. I just wanted to. This is a shader, and it's very terse. A very terse amount of code in one line, or however 6 lines, to render everything that you see on the screen. So it's run per pixel, and it's run on the GPU, which is why you can have such a small change affect it so greatly. And I was thinking about how it can be a little bit dense and difficult to kind of get into right away. And so I took a step back, and I started thinking about the interface, specifically the mouse, and how the mouse is the representation of you on the computer, right? That's you, your hand, touching things on your computer. So I was thinking about, what if, instead of it being the way that we usually think about it, what if it could be a drawing instrument, something that scratched? Or maybe the mouse, the cursor, could be something that highlighted text that was hidden. And so I just made this series of cursors to really experiment with the interface as a starting point, to kind of set the tone for the IDE explorations. And so a main question that I was thinking about is, how can IDEs be more conducive for creative coding? And if you need a touch-up on what IDE stands for, it stands for Integrative Development Environment. It's basically the software that we use to make software. And then that brings us to the next algorithm. And that algorithm is algorithms as thoughts. I know, has the Livecode manifesto come up today in these talk series yet? No, it has not. Sick. And you better believe I'm gonna read the last line of this. So I needed to, I'm very happy that, if you haven't seen this before, I'm very happy to be the first person to ever show you this. And it is the manifesto draft, and it was created in 2011. I think, Kate Sicchio, you were there at the beginning. Yes, maybe.
I didn't write the
original napkin. Wow, so this was on a napkin. Fun fact, folks. Wow. And it is always going to be called a draft in the spirit of live coding. And it's really fun. So the line that I'm going to highlight is the last line. And it is, algorithms are thoughts, chainsaws are tools. That's why algorithms are sometimes harder to notice than chainsaws. We're all going to say it all at once if it ever comes again during this talk series. So yeah, we're going to remember that. So I've been doing a lot of thinking about thinking and writing software that writes software. And so I wanted to think about, okay, where is the creative coding IDE right now? This is processing and P5.js IDE. And Casey Rees and Ben Fry they have said, I read that they said that they wanted the IDE to be they wanted there to be a big play button and a big stop button, so there would be no ambiguity of what the IDE does, which is perfect for someone who's starting to code. And P5.js was influenced by that, as was Arduino. So all of these IDEs were influenced by this decision. And a lot of times folks will, after they understand how P5 and processing works and that they exist in a larger coding ecosystem, sometimes these IDEs are shed. And I wanted to show another IDE. And we're getting a little more niche. This is Touch Designer, which is going to be used at this conference. And I always say Touch Designer tricks the user into programming. You're not programming. You're moving nodes around. But when I use Touch Designer, I always want to open it up and edit the code. But you can have nodes that have code in them, but for the whole sketch, for the whole program, you can't edit the code for it. And what a lot of graphics creative coders end up using are tools that were made for software engineers. So this is how I used to program all of my graphics in my creative coding projects, was in something like Visual Studio. And this is just the vast majority of IDEs. So like all of these are different IDEs, but they all have the same paradigm of like code here and then like your files, so on and so forth. And it's because it's for software engineering. And so I was thinking about like, okay, what if there's something in between P5.js and Visual Studio Code? And so I was thinking a lot about what I personally would want in my IDE, and so I made my own. And I call it Fantasy IDE. And in Fantasy IDEs, there's node-based programming, and then you can open up the JavaScript side to see the code that makes the nodes, or the tiles. And you can see the visual flow going from CPU code, like grabbing a webcam, to GPU code, like a shader, and then back to CPU code, like this JavaScript text box. And you might be noticing that I'm calling these tiles, or actually I haven't been good at calling them tiles, but they are called tiles. And that's really just for the pun of it being Char's tiles. So back to this question of how can IDEs be more conducive for creative coding? And I've been thinking about it, and perhaps the larger question that I've been thinking about for years is, if programming is the native language of our digital age, does that make computation the artistic material of our time? And so thinking about thoughts as algorithms, I have to bring up the LLMs. And every time I have a stage, I always want to just talk about our approach to this because it's getting so popular, or my approach to LLMs because it's getting so popular. We don't really need a study to tell us this, but there is a study that shows through brain scans, when you use OpenAI to write an essay, there is less brain activity than if you were to write the essay on your own. I know I didn't need a study to tell me that because I can feel it in my brain. Whenever I code with an LLM, it feels like it's just going in there and doing it for me, right? It's a common kind of process. And so I was thinking about in my IDE, how can AI be used in a way where it does anything but help write code for you, right? And this narrative of LLMs replacing the need to know how to code is spun by none other the man who makes the machines to do so. So this is Jensen, he's the CEO of NVIDIA, and he says that kids shouldn't learn to program or to code, they should leave it up to AI, and I super disagree with this. I think like there will be vibe coders and people who are using AI to vibe code applications, but it's not going to replace coders because it's just going to expand the definition of what a coder, of who's working with code, right? It's like the same way when electronic music came out. It was like, oh, this is electronic music. But then as more and more music was being made, there was more subdivisions. And more broadly, I think about this question, which was asked in New Consumer 2024, and I found out about it through Yancey Stickler's Dark Anthology of the Internet. And I read this, and it says, more Gen Z consumers feel like they feel that more like themselves online than offline. And I saw this, and I said, big, if true. Because this is a question that was asked by a consumer report, right? So where are their intentions at? This could be actually asked, this could be more of like the definition of online and offline is changing. It could also be that the definition of where do you feel like yourself is changing. It doesn't necessarily mean what it seems to imply. And so I've been working with a Berkeley lab called the Belief Lab to really pick apart this question and find out what is actually trending. Because it has such big implications, right? So if online platforms are now places where people can truly express themselves, that means that it's more infrastructure than a platform. And that changes how we relate to those companies, to those platforms. And so again, I was thinking about how can AI be used in a way that expands your world instead of shrinking it, right? Instead of writing code for you, doing it for you. Because especially as a creative coder, the code itself is the artwork. And so why would I want an AI touching my art, doing my art for me? Much like how the Solowitz wall drawings, like the text itself is the art, not necessarily the output. And there is a well-documented homogenization effect of LLMs, right? So if you're using an LLM, it will like kind of guide you towards what the most common thing to do is. And so instead of having it guide me or lead me or give me ideas, I decided to have it make references. So as I was coding in my IDE, it would take snapshots, checkpoints, in my code, and then search through an art API and make artistic references. So these are so the top is what I coded. The middle is what the AI described it as, and it also used the code to get the description. And then the bottom is the artistic references that it made. So in the middle, there is a Duchamp spiral, right there. I didn't know that Duchamp had a spiral phase. And then on the right, there's Mondrian snowflakes. I also didn't know that Mondrian made snowflakes. And so in this way, I found that it could expand my world instead of shrinking it. And again, it is not perfect. Like, for example, it made this reference to Klein Blue, right? So that's the top that I made, and it's like, oh, that looks like Klein Blue. Great reference, but then the art, so the API that grabs the art pieces, that isn't AI, that's just like a lookup. You know, you just look up the artwork and see if it's there, and it didn't have it, so it just grabbed this other Yves Klein piece. And so another way I was thinking about this is like, okay, if I have all these artistic references, I could look through the different versions of my code by interpolating through latent space of artistic movements. So here it is in kind of like in a structured order. And then I can also change the mode here and then have it in latent space. So there's more like abstract pieces here. There's more abstract pieces at the bottom and more representational references at the top. Another way that I've been thinking about how, including AI can expand my practice is including other people into what I do. So here's, this was actually in this very room 2 years ago, and I included a chatbot inside of my IDE that the audience members could connect to and then ask questions about the code and to be able to understand more and feel like they're part of like part of something in the performance. So they can feel like they're part of the performance even. And so here's my friend Indira. Yes, please explain the code. Girly, and it did do it kind of in a verbose way. But it's also, what I found out, what was even better, was that the audience members could talk to each other through this, and also talk to me through it. So when I used it here, my professor Golan was like, there's too much fog, you gotta turn down the fog, which is a really great way of using this. You might be wondering, how did I make this IDE? What libraries do I use? It's all written in JavaScript. Oh, shoot. And so I've been taking this IDE and I've been performing it in different places. And this is a performance that I did at South by Southwest with this group called, at Data Labs, with CJ and Zach. And they had such great energy. So they're making the music and I'm making the bouncing tiles. And at one point, Zach fell down during the performance. And I asked him, I was like, how did that happen? What got you so riled up? And he was like, we were just trying to keep up with the tiles. And it kind of created this feedback loop of they would jump more and then I would create the tiles to jump more. Yeah. And so I've also been, another fun thing that's kind of emerged from using my own IDEs, that I made it a very important part of this IDE is to easily get inputs and outputs. And so I would take inputs from my text editor, and then I would say things like, we were taking programming language requests, and talk to the audience in that way. And anyways, through all of this exploration in IDEs, I think that talking about IDEs and making workshops for people to create their own IDEs is a really nice way to get started into thinking about your own digital agency, right? Because ultimately, a lot of live coders will make their own programming languages, and you will see a lot of really exciting examples of that next for Daniel's talk. But I also think that there's a place for the interface and the IDE to be a place to start to think about what's particular to you in your digital environment, and to feel more agency in the coding environments that are becoming more ubiquitous. Yeah, so that's the algorithms of thinking about algorithms as thought. Now, the next algorithm that I wanted to talk to you about while talking about my story is spherical harmonics. And we'll get to why it's spherical harmonics in a second. But before I do that, you might be wondering, because in all of the videos that I've shown and all of the things that I talked about, I obviously do visuals, but sometimes I'm alone on stage, or sometimes, it's confusing. Sometimes people think I'm a musician too, because of that kind of, I'm on stage, and that's kind of the grammar of what a musician does. They're on stage and they make music. And so finally this summer I gave in. And I was like, okay, I'm a musician. I also started making music. And I started sketching and posting my sketches online, just to see where it goes and where it takes me. And so I did this one very simple intro to Strudel. And working with Strudel I know we have some Strudel developers in the audience, so shout out to the Strudel developers. Working with Strudel is just so much fun, because similarly to how I was able to play around with physically based algorithms for visuals, like ray marching, I'm also able to play around with physically based tuning systems in Strudel. So I added this slide in yesterday, inspired by Tyler's talk. So Tyler talked a lot about how you could really play around with music theory and different tuning systems. And so this past summer, I was hanging out with some contemporary music composers, and one of them, Emanuele Savagnone, told me about just tuning systems. So, in case you weren't aware, like I was a mere summer ago, that Western music has a little apostrophe on it. In the way that we think that the 12 octaves is an even kind of step from the next 12 octaves, that's the kind of conventional way we think about Western music, is that, each octave is divided by 12, and they fit perfectly into each other, and it creates these beautiful necklaces. There's an apostrophe, and it's called the Pythagorean comma, aka the wolf note. Has anyone heard of this? Okay, great, yes, I like that. It's like a 50-50, because I'm gonna bring you guys all on board with this, because it blew my mind. Basically, what it is that 12 octaves are actually fudged a little bit on the last like triangle of the necklace. There's like because if you divide the frequency equally into like actually perfect 12 notes, it just kind of sounds bad at the last when you play the last two notes. So I created a strudel sketch that demonstrates this. So here we have strudel. Here we go. So here is like the perfect. If you were to here, I'm going to go back a little bit. Oh, can I? So if you were to divide, like you see the. Hold on, I want to pause this. Can I pause it? No, I can't. Alas. Well, I'm just going to have to talk over it. So. You can use strudel to show, like here I'm using, I create an array that is the notes divided equally, and you can see how the wheel doesn't exactly meet where the, this is the slide that I just added, so you guys are you're really my experimental crowd for this. But basically, here you can see in the final, the way that I show it, is that you can see that using the mathematically generated frequencies, there is this kind of offset. So in the octaves, the final note is a little bit off from where the final note should land. So like I computed what a C4 should be given the previous octave, and then I showed what it actually is. So basically, what it shows is that the going from one octave to another, there's some sort of like mathematical fudging just because it sounds better that way. Okay, that was rough. Thanks for staying with me, guys. And the line between the physical and the digital is always pretty blurry. And I always like to think at that boundary, there can be a lot of optical illusions. So this is a hatimation that I made. And the hatimation shows the blurry boundaries between physical and digital because it's actually 8 hats instead of 1 hat with a moving hat on it. And so, yeah. And so, wow, yeah, talking about just fifths got me, let's go back, let's become more grounded again. Okay, so I've been thinking a lot about this boundary between the physical and the digital. And I started to make hardware. And this was inspired by a class that I took called How to Make Almost Anything. And it was a wonderful class. Through a semester, it walked you through all the steps of electronic manufacturing, right? So from designing a PCB to cutting it out to stuffing it, which means like soldering it, to make a electronic object. And I had a really good time with this. I found this program that let you code your PCBs instead of using like a PCB software, and I had a lot of fun with that, animating it. Oh, and I also made, I guess this is like a button that I made. Cool, buttons. And I was thinking about how live coding can be a part of this practice of electronic manufacturing, and so, or like digital physical manufacturing. And so I wrote this program that live coded a laser cutter. And basically all it is, it just sends serial G code to a laser cutter live, and the laser cutter responds to the G code by moving the nozzle. And so I was live coding a song, and then as I was live coding, it would move the nozzle up and down, kind of like analogous to how records are made. And I wanted to show this other project just because I'm going to use it later tonight. And this is it right here. It's that glowing thing in my hair. And I debuted it. This was in January when I did a month-long residency at Shenzhen. which is the place in the world where 80 to 90% of all consumer electronics are made and manufactured. And it was a really great place to just see all of the concentrated knowledge about conjuring objects into existence. And here's a better look at it. So it's a microphone, it's a headset. Someone asked me, what's that glowing thing in your hair? And it's a custom hardware for LED microphone, for microphone and headphones that a collaborator and I made. And he lives in Shenzhen, so he was really, he knew all about manufacturing and how to put it together. So I learned a lot from working with him. Oh, very cool, very cyber. And then I wrote some code that would send MIDI from my music to the headphones, and it changed the LEDs. Cool. And also inside of it is an IMU sensor, which would then go back to my code and change the values through that. And so this is just the IMU sensor outside of the, oh, I guess it's quiet. Oh, well. Well, you'll just have to, oh, there it is. So it changes variables inside of my code based on where it's facing. So again, I know I talked about how this was going to relate to spherical harmonics, and I will, but at first I wanted to talk about a different application of spherical harmonics. So that was, so how spherical harmonics are used in this next project is through Gaussian splatting. So this is a project that I made going back to my visual practice, but again, still existing at the blurry boundary of the digital and the physical. Gaussian splatting was an algorithm Gaussian splatting is actually an algorithm that has been very popular since the 90s, but it kind of got repopularized because it was combined with a neural NERF, a neural radiance field, so that you could see different parts of the splats from different angles. So you could have view-dependent reflections and things like that. So I did this, I made this renderer of Gaussian splat neural radiance fields in open frameworks as a collaboration with Zach Lieberman. And then I used it for a collaboration with DJ Dave, who's an artist who I have been working with for some years now. And the fun thing about Gaussian splatting is that it uses these little blurry pieces of rice instead of a mesh. So you can do things that you can't necessarily easily do with glitching out a mesh, or it's just a new way of rendering that I had a lot of fun with breaking, as live coders like to do often. And I made these different views of just portraits. And so how it creates that view-dependent part is through spherical harmonics. So basically, spherical harmonics are kind of like a Fourier transform, but instead of a 2D wave, it's on 3D, so that you can be able to, and then you can use it to describe which color to see from which angle. So you have a spherical harmonic function, and that describes at which color you should see at what angle. So how does this relate to all the music stuff that I was talking about? Well, I took a class at IRCAM by Emanuele Carmine, sorry, different Emanuele. And he talked a lot about spherical harmonics in its relation to physical sound systems and physically located sound. So you can, when you're creating sound for a surround sound system, you can use spherical harmonics to describe which sounds come from which directions. And in that class, we entered this room. So this room is the anagoric chamber. And there's a little story about the anagoric chamber, and a different one in Harvard. There's a story that John Cage went to an anagoric chamber in Harvard, and what anagoric means is that it has no echoes, it's anagoric. And so what happens then is that you can just hear sound as it comes from the starting location, and you don't hear how it bounces off the rest of the room. And there's a story that goes, John Cage spent some time in an anagoric chamber, and he asked the technician, I heard two sounds. I heard a low humming sound, and I heard a high-pitched squeal. What were those sounds? And the technician goes, the lower sound was your blood, and the higher sound was your nervous system. And this story, perhaps, is not true, because that isn't true. when you hear sounds in an anechoic chamber, it is not your nervous system nor your blood. But regardless of if it's true or not, the story goes that then John Cage decided to write 433, inspired by the anechoic chamber. So I was thinking about that a lot, and I was thinking, wouldn't it be funny if I sampled silence and then I live coded with it? And so I made this video where I recorded my surroundings, and then I imported it into Strudel very quickly. And there it is in Strudel. And then I build up from there, just writing code and starting to speed it up and kind of mess with it, and it builds up to this song, which is kind of like exactly what John Cage wouldn't want you to do. And anyway, so I posted it online, and the funniest thing possible happened to this video. Whose copyright? I think that this was really John Cage's ghost, just saying, you tried to make music out of nothing? Haha. Okay, and so that was spherical harmonics. Finally, the last algorithm that I want to talk to you about is this algorithm called Rayleigh scattering. So this also starts with the story. So this is after I graduated, we're coming to the current day. I was looking at the sky with my lab mates, and we were talking about how the sky is blue. And we both were kind of like, yeah, it's something to do with scattering. Yeah, it's like, oh, yeah, there's things in the sky that cause the light to scatter, and that's why it's blue. We didn't really have like a definite answer. And I was just like, I really want to know this, and I want to use my physically based hunch for using, physically based algorithms to kind of experiment with this. And so I found this paper that talks about how you can you could write a shader to create an algorithm for atmospheric scattering. So I coded it up, and when I rendered it, the sky was purple. Okay. Some of you who might know the algorithm Rayleigh scattering might know where I'm going with this. So basically what Rayleigh scattering says is that the sky is blue because the shorter wavelengths get caught in the atmosphere, and then the other wavelengths pass through. So that's why the blue light, which is on the shorter end, is reflected in the sky. And it makes sense that when I rendered it, it was purple, because purple is a shorter wavelength than blue. And this is when I found out that the sun doesn't have all of the wavelengths of light evenly in it. So if you were to take a spectrometer, I think that's what this is called, of sunlight, you will see that there is actually more blue light than purple light that makes up sunlight. So I changed my algorithm input to be composed of more blue light, and then we got a blue sky. Next thing I wanted to do was to render a sunset. And it makes sense that the sunset is red because you have more atmosphere to look through as the sun sets. So then the longer wavelengths get caught in the sky as well. So that's why it goes from blue to the longer wavelengths. When I coded it up, the sky was green at some point. And I didn't miss this day in kindergarten. I know that between blue and red is green. And I even asked AI, and AI said, because the atmosphere scatters more blue light than red light, that doesn't make any sense. That's not even relevant. And it was just very wrong. And I looked it up more, and there's a lot of reasons why sunsets aren't green. And some of them are, it's there, it's just mixed in. Green light scatters more. Different atmospheric particles scatters green light in a different way. And so I just went with green scatters more. So I implemented that in my code. And then I got my beautiful red sunset. And it was really through through this exploration that I didn't learn to ask why the sky was blue, but I learned to ask why isn't the sky purple and why aren't sunsets green? And finally, I wanted to come back to the first algorithm that I talked about, the humble for loop. And I was thinking a lot about how all these algorithms have led me to where I am today. And I thought it would be nice in my thesis if I dedicated my thesis to my favorite first algorithm. So my thesis is dedicated to loop, for loop. Thank you.
Amazing. Kind of loud there. Thank you, Char. That was incredible. We are somewhat tight on time, so apologies. We will kind of try and keep the questions for other people. The reason for keeping it tight, we've got Daniel next, but then after that, we also have all the sound checks for later this evening, so just so things don't rush too late and everyone has plenty time for sound checking. So thanks again, Char.
Yeah, come find me if you have questions.
So Daniel that's coming up, he was actually here a couple